To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. So today again I'm going to continue extra questions related to current electricity. In the previous chapters also we discussed some extra questions, and as you know from in the lesson we have discussed static electricity and current electricity. Then with current electricity we discussed different quantities, the electromotive force, potential difference, current and resistance. And then we discussed the Ohm's law and the relationship between the potential difference and the current flow through a conductor. Thereafter, we discussed what resistors are, the different types of resistors and the different combination of resistors. So you have been answering questions related to this particular lesson. Now I am going to continue. Extra question 21. The first question, what are variable resistors? So you're familiar with resistors. Why do we use resistors? To control the current flow through a circuit. So why do we use variable resistors, or what are variable resistors? A resistor of which the resistance can be adjusted according to our requirement. So that is a variable resistor. So here we can say resistors made in such a way that the resistance can be adjusted based on requirement. That is, if you need a certain value, you can change the resistance of the resistor. Then, the second part of the question, write examples of variable resistors. We have looked at different types of variable resistors. We have used the rheostat in the laboratory. Then I showed you all the volume control resistor, and also there is the pre-adjustment resistor. The three different types of, or three different examples of variable resistors. So rheostat. Then we have the pre-adjustment resistor, and the volume control resistor. So rheostat, pre-adjustment resistor and volume control resistor. Then the third one, write an application of variable resistors. Now we have used variable resistors in the lab when we try to verify the Ohm's law to identify the relationship between potential difference and current. We use the rheostat. So in laboratory activities you can use the variable resistor. Where else can you use variable resistors? To change the volume of a radio, to control the volume of a radio, you can use the volume control resistor. And also in electronic circuits, you can use variable resistors. They are also usually the volume control resistor is used. So I have told you all this before also. It doesn't have to be that always there is sound involved when we use a volume control resistor. You can use it in the radio to control the volume, or else you can use the same volume control resistor in an electronic circuit in order to change the resistance of the circuit. Either way, you can use that as well. So those are the applications of variable resistors, using them in laboratory activities, using them to control the volume of radio, and also in electronic circuits. You can write any one of the three. So I will say used in laboratory activities. Used in laboratory activities. Example, rheostat used in the activity related to Ohm's law. So that is an application. If we look at the questions, what are variable resistors? Resistors made in such a way that the resistance can be adjusted based on requirement. So here students, this is just to understand what variable resistors are. So there is no definition, exact definition for a variable resistor. You just need to explain it. What are variable resistors? Then write examples of variable resistors. Rheostat, pre-adjustment resistor, and volume control resistor. Then the last one, write an application of variable resistors. It is used in laboratory activities. I have given an example. Rheostat used in the activity related to Ohm's law. In addition to that, if you all like, you can say used to control the volume of radio and also used in electronic circuits. You can write any one of the applications. I am sure you all would have done that correctly. With that, students, I'll move on to the next question. Extra question 22. Write the meaning of LDR. What is LDR? Light dependent resistors. So here you have to say light dependent resistor. And write a use of LDR. Where do we use LDRs? To change the resistance depending on the light intensity. So here we can say to change the resistance depending on the intensity of light. To change the resistance depending on the intensity of light. So that is why we say LDR, light dependent resistor. When the intensity of light falling on the resistor is less, the resistance is high. When the intensity of light falling on the resistor, that is LDR, is less, that is in the darkness, the resistance will be high. And when the intensity of light falling on the LDR is high, the resistance is less. So in other words, we can say when the light intensity falling on the resistor increases, the resistance decreases. That is how the LDR functions, light dependent resistor. Then we need to draw the circuit symbol of LDR. Draw the circuit symbol of LDR. The circuit symbol where we have, then we have the circuit symbol, but you need to show arrows to indicate that it is the light dependent resistor. Always the arrowhead should be directed towards the resistor. So this is the normal circuit symbol for a resistor. The zigzag lines, you have to have a circle and then show arrowheads pointing towards the resistor. That is the circuit symbol of LDR, light dependent resistor. So I am sure students, you have also answered this correctly. With that, I'll move on to the next question. So for the first question, students, what are permanent resistors? This is again, like I told you all, another name for fixed value resistors. So in fixed value resistors, the value of resistance cannot be changed. So that is what we need to write there. Resistors with values that cannot be changed are known as permanent resistors or fixed value resistors. Permanent resistors or fixed value resistors. So the concept is that you cannot change the resistance of a fixed value resistor. You are familiar with different values like 5 ohm, 10 ohm, 20 ohm, 100 ohm, even 1000, 10,000. You have different values, but for a particular resistor, the value does not change. And you are familiar with calculating or determining the resistance of a fixed value resistor using the color bands. So that is a fixed value resistor, or another name is permanent resistors. So here these are fixed value resistors. Fixed value resistors. Then the next question, write the two methods of combining resistors. What are the two methods? The series combination of resistors and parallel combination of resistors. So first one, series combination. You can just say series combination, or you can write a series combination of resistors. And the second one, parallel combination. Parallel combination. And you all know, students, from experience, from when you calculated the equivalent resistance, when it is series combination, the resistance gets added up. Whereas in parallel combination, since we calculate the reciprocal of equivalent resistance as equal to reciprocal of the individual resistors, the resistance is usually less. So that is how the two combinations work. You all should have that in mind as well. So with that, we'll move on to the next question. Extra question 24. So first, you can see, consider the circuit given. So look at the circuit. Here you can see voltage, that is potential difference, marked as V. That is a dry cell, a battery. Then from there, they have indicated the current flow I. And at this point, there are three resistors R1, R2 and R3 connected in what manner? A parallel combination. And at the point X here, current gets divided into I1, I2 and I3. And again here you can see point Y. So you all know, when the resistors are connected in a parallel manner, the potential difference across these 2 points, that is the same value. That does not change. But the current flowing through the resistors depends on the resistance. Actually, this total current divides according to the resistance. Less resistance, more current. More resistance, less current. If the resistance are equal, then the current is also divided equally. So those are the things that you have to remember when answering a question like this. And again, at this point, all the current that is flowing through R1, R2 and R3 combine, and the total current will flow back to the battery. So those are the information that you can get from the diagram. Then if we look at the questions, write an equation for the current flowing through R1. What is the current? There it is given as I1. Normally, you all know, students, if we write the relationship, we have the equation V equals IR. From that, you can rearrange I is equal to V over R. So, here the potential difference is given as V. Through each resistor, the current is given as I1, I2 and I3 respectively. So, there. To answer the question, first one, write an equation for the current flowing through R1. So, that is going to be I1. That will be equal to V over R1. Potential difference, like I said, is the same value across all the resistors, that is between point X and point Y. So, I1 is equal to V over R1. Second question, write an equation for the current flowing through R2. So, that is going to be I2. Here you can see through R2 current flow is I2. That is again equal to the same potential difference V divided by R2. So, I1 and this is I2. Then, the third question, write an equation for the current flowing through R3. So, here you can see R3 current flow is I3. I3 will be equal to V over R3. So, in all these three, you can see, students, potential difference does not change. Always in a parallel combination of resistors, the potential difference across the resistors is the same value. But since the resistance changes, current also depends on the resistance, or current also changes. But if the resistance are equal, if the resistors have equal resistance, then the current flowing through the resistors will be equal. If the resistors are different, accordingly the current flow will be also different. So, this is how we get the relationship to calculate the equivalent resistance using these equations. So, I'll move on to the next slide where we continue the question. Write a relationship between I and I1, I2 and I3. So, I is what? It is the total current flowing through the circuit, that is divided as I1, I2 and I3. So, I is equal to I1 plus I2 plus I3. That is the relationship. Then, what is the potential difference between points X and Y? Potential difference is V. Potential difference V. So, these are all quantities related to the circuit. We'll move on to the next part of the question. Derive an equation to calculate the equivalent resistance of the circuit using the above relationship. So, here V is the same across the resistors R1, R2 and R3. Then I is the total current, that is equal to I1 plus I2 plus I3. Then what can we do? Substitute for current. That will be equal to V potential difference over R. R is the equivalent resistance. That will be equal to V over R1 plus V over R2 plus V over R3. Then you all know in maths, the next step what I am going to write is optional. You can skip that step as well. So, here V over R, we can take the V out, then 1 over R1 plus 1 over R2 plus 1 over R3. Why? Here V is a common factor. So, we can take the V out, you get the equation as this way. So this side also we have V over R. So the V and V will be cancelled off. So from this, you will get the relationship 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3, where R is the equivalent resistance. So here we have the relationship for reciprocal of equivalent resistance. 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So again, to calculate the equivalent resistance, you take the reciprocal of this particular value. I am sure you can remember that calculation. So from all the questions, this is what we were able to derive. Potential difference V is the same across the resistors R1, R2 and R3. Then we wrote this equation, the relationship for current I is equal to I1 plus I2 plus I3. So there, in that equation, if you substitute for current, V over R, R is the equivalent resistance, equals V over R1 plus V over R2 plus V over R3. Like I said, this step is optional. From here, you can directly write this as well, because V does not change. So V over R equals V into 1 over R plus 1 over R2 plus 1 over R3, that is given in brackets because V is the common factor. You can cancel it off from either side. So 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And R is the equivalent resistance of the circuit. So this is how we get the relationship. So with that, students, I will move on to the next slide. We have extra question 25. Here also we have a circuit. Now you can look at the circuit there. You can see 6 volt potential difference. Then from there, current flows this way. Point A, between point A and point B, there is a resistance R1. Value is 9 ohms. Then from after point B, it divides into 2, where you have 2 resistors, R2 and R3. R2 is 4 ohms, R3 is 12 ohms. So if you take R2 and R3, they are connected in the parallel combination. But these two together with R1, it is a series combination. So this part is in series with R1. We have discussed similar questions like this before. I have explained how to calculate equivalent resistance for these type of combinations. Then you have A1 and A2 ammeters. A1 measures the current flow through R2 and A2 measures the current flow through R3. Then again the current will combine at this point, and through C the same current will flow, and that can be measured using A3 ammeter. A1, A2, A3, they are ammeters to measure the current flow. So that is how the circuit is. This along with these two is the series combination, whereas R2 and R3, it is a parallel combination. So what happens to the potential difference? Now we can see potential difference will be distributed between AB points and BC points here. Between AB there will be a potential difference. Between BC there will be a potential difference. That is how in series combination the potential difference is divided. Now from this point current will get divided, but between these 2 points and between R1 or across R1 and through this, the total current is going to be the same. You all have to combine all the knowledge that you have related to combination of resistors. Then, if we look at the questions. Find the equivalent resistance between points B and C. So, between B and C, this is again for your information, just for you all to recall and understand. I am writing all this. You need to only do the calculation between B and C parallel combination. So if it is a parallel combination, how do we find the equivalent resistance? 1 over R is equal to 1 over R2. Here we have R2 and 1 over R3. So then, if we substitute the values, 1 over 4 plus 1 over 12. Since the denominators are different, you need to find the least common multiple. So there, 4 and 12, it's 12. So 4 into 3 is 12. So 3 into 1, 3 plus 1 over 12. So that is going to be 4 over 12. Then if you calculate the equivalent resistance, that is 12 over 4 equals to 3 ohms. So we have calculated the equivalent resistance between B and C, R2 and R3, 4 ohm and 12 ohm. So it is a parallel combination. So calculating equivalent resistance is done by this equation. 1 over R is equal to 1 over R2 plus 1 over R3. So that is equal to 1 over 4 plus 1 over 12. That is 3 over 12 plus 1 over 12. You get 4 over 12. And the equivalent resistance, you again take the reciprocal. R is equal to 12 divided by 4. That is 3 ohms. So we have calculated the equivalent resistance between B and C. Then the next part of the question, the same circuit is given to you, so you are familiar with that. Find the equivalent resistance between points A and C. This 9 ohm and the 3 ohm that we calculated here are in series combination. So then we can calculate the equivalent resistance. How do we do that? R is equal to R1 plus, I will write it as R dash. So there it is going to be 9 ohms plus 3 ohms. That is equal to 9 plus 3, 12 ohms. That is the equivalent resistance of the circuit, or between points A and C. Here what I have denoted as R dash is what we calculated here. So here also I will use it as R dash. So that is the equivalent resistance there. Then we will move on to the next part of the question. Again the same circuit. The third question, write the letter corresponding to the ammeter that shows the current flowing through the circuit. Through the circuit, it is A3. Ammeter A3. Why? Current flows this way. Current through R1, then divides through R2 and R3, again combines, and then the total current flows through A3. So ammeter 3, A3 corresponds to the, or shows the current flowing through the circuit. Then calculate the current flowing through the circuit. How do we calculate the current flowing through the circuit? You have the potential difference V, that is 6 volts. So 6 volts, and what was the equivalent resistance that we calculated for the circuit? 12 ohms. Between these two, it was 3 ohms. And then we calculated the equivalent resistance between points A and C as 12 ohms. You can remember that here. You can see that is the equivalent resistance between points A and C, 12 ohms. So based on that, these are the values. So to calculate the current flow, what do? V equals IR. Like I said, V 6 volts. We need to calculate current, and R is 12 ohms. You can substitute and make I as the subject, or you can rearrange and do the calculation. So here I will be equal to 6 volts divided by 12 ohms, that is 0.5 amperes. Why 6 divided by 12? 0.5 amperes. The same thing, students, like I said before, what you can do is you have the equation V equals IR. You can rearrange it and then substitute and do the calculation. Either way is fine. So here we have calculated the current flowing through the circuit. V equals IR, 6 volts equals I into 12 ohms. So I is 6 volts divided by 12 ohms, 0.5 ampere current. Then the next part, again the same circuit, calculate the potential difference between points A and B. So between points A and B, potential difference equals I into R. So here we know the current, the total current flows through R1. So that is 0.5 amperes. We calculated I as 0.5 amperes. Then R is given to us 9 ohms. 9 ohm is the resistance. So 0.5 into 9, that is 4.5 volts. Potential difference is 4.5 volts. So out of this 12 volts, you can see here between these 2 points it is 4.5 volts. Then obviously you all can understand between points B and C it is the rest. Total potential difference is 6 volts. So between A and B it is 4.5 volts. So between B and C it will be 6 minus 4.5, that is 1.5 volts. Between B and C. That you have to remember. Between A and B, this is what I explained to you all. According to the resistance, the potential difference will be divided if it is a series combination of resistors. Now R1 and this part, they are like series combination. And the potential difference across A and B or between A and B is 4.5 volts. I am sure you all can understand that. Then, is this clear to you all, students? We have calculated the potential difference between points A and B. Use the equation V equals IR. Total current flows through R1, 0.5 amperes. And the resistance 9 ohms, so 4.5 volts. I will move on to the next part. Again the same circuit. Calculate the potential difference between points B and C. Now in the previous slide, students, I showed you all one way of calculating the potential difference there. Now you can remember. We calculated, now here the potential difference is given as 6 volts. Between points A and B, we calculated the potential difference 4.5 volts. Then I told you all, or you all can understand, in a series combination. Now this one and this whole unit of resistors is in series combination. So according to the resistance, potential difference will be distributed. Now here 9 ohm resistance, here the equivalent resistance was 3 ohms. So when it is 9 ohm and 3 ohm, you can remember, students, according to the ratio. 9 ohm is to 3 ohm. So it is 3:1. Potential difference also is divided accordingly. Total is 6 volts. 3 plus 1, 4. If you divide 6 by 4, 1.5. Out of that, 4.5 goes to this and 1.5 goes to that. This is a shortcut method that you can use to confirm your answer. Or else you can see. Now 6 volts is here. Out of that 4.5 has go on to the R1. The rest will be for this component between B and C. So 6 minus 4.5, we calculated it as 1.5 volts. That is one method of calculating the potential difference between B and C. At the same time, now we are used to calculating all these quantities using the equation for Ohm's law. So how do we do that? V equals IR. Now what is the current? At this point, from through B, you all know 0.5 amperes enters into this component. Then it divides between R2 and R3. But again, at this point also, it combines to become 0.5 amperes. So a total of 0.5 will flow through this part. Then what do we do? Here we have I 0.5 amperes and we have calculated the equivalent resistance 3 ohms. So 0.5 amperes into 3 ohms, you will get the value as 1.5 volt. Is that clear to you all? So you can use any method. You can use this method to calculate, or the first method where you consider the total potential difference, subtract the potential difference between points A and B to find the potential difference between B and C. So that is same as calculating here. You will get the same answer. You will have to get the same answer. But like I told you all before, if you are doing an MCQ, you can look at the ratio between the resistors and accordingly you can calculate the potential difference. More potential difference across higher resistor. Less potential difference across less resistance. That is what you have to remember. Is that clear, student? So then with that, we'll move on to the next slide. Again, the same circuit. Calculate the current that flow through the 9 ohm resistor. So we have already calculated that. Current flow through 9 ohm resistor. The total current that flows through 9 ohm resistor. So here 0.5 amperes. Because the same current that flows through the circuit. If you are to calculate also, you know. How do we calculate? V equals IR. I is equal to V over R. Potential difference across that is 4.5 volts divided by 9 ohms. 4.5 divided by 9 ohms, 0.5 amperes. The same thing. So we already have same current through circuit. So the same current through circuit, or you can calculate it. The current flow through the 9 ohm resistor. You have the resistance here. We have calculated the potential difference. So potential difference divided by resistance, you get the value as 0.5 amperes. Is that clear? In one of the previous parts, we calculated the same thing, but that is the total current flowing through the circuit. There we considered the potential difference and what did we consider? The total potential difference, that is 6 volts, and the total resistance, that is the equivalent resistance between points A and C. You can remember that. So from this you all can understand and confirm that the current flowing through resistor R1 is the same current that flows through the circuit. That is 0.5 amperes. Is that clear to you all, students? So then we'll move on to the next slide. Same question, same diagram. The next part. Calculate the current flow through the circuit if R2 is removed. Now, if R2 is removed, what will happen? We have R1. R2 is removed means you will have R3 in series combination with R1. R1 9 ohms and R3 12 ohms. Calculate the current flow through the circuit if R2 is removed. So this is how the resistors are going to be. They will be like a series combination. So then how do we get the equivalent resistance? Equivalent resistance R1 plus R3. So that is equal to 9 ohms plus 12 ohms. 21 ohms. 9 ohm plus 12 ohm, 21 ohms. Current flow through the circuit. V equals IR. I is equal to V over R. What is the potential difference we consider here? The 6 volt potential difference. 6 volts. And the equivalent resistance is 21 ohms. So 6 over 21, we can simplify it with 3. So that is going to be, if you divide 6 by 3, 2, and 21 by 3, it's going to be 7. So 2 over 7 amperes. You can leave it as it is, or you can simplify and write the decimal value. Here if we divide 2 by 7, 0. So 20, we have 2 times 14, then 6, 8, 56, 40, then it becomes 5. So we can simplify, you can round off the value, you can either write it as 0.285 or we can write it as 0.3 amperes. I will round it off to the first decimal value, 0.285 amperes. That can be taken as 0.3 amperes also. We don't have to go into so many decimals. You all just need to understand what happens here. So from this calculation, students, you all can see when one resistor that was connected parallelly is removed, the other two become a series combination. Because of that, the equivalent resistance increases, and because of that, the current flow has decreased. That is what you need to understand here. We have discussed all these concepts before, but this is for you all to understand how it happens. So we were supposed to calculate the current flow through the circuit if R2 is removed. So you calculate the equivalent resistance, R1 and R3 added together 9 ohm and 12 ohm, 21 ohm. Then from V equals IR, we calculate current dividing 6 volts by 21 ohms. So 2 over 7. That is equal to 0.285 amperes or 0.3 amperes. You can see the current has decreased. So with that, students, I'm sure you all have understood this question and you would have also done the calculations correctly. With that, I'm going to move on to the next slide. Extra question 26. The potential difference of a car battery is 12 volts. The battery is made by combining 6 2-volt batteries. So the potential difference of a car battery is 12 volts. The battery is made by combining 6 2-volt batteries. Now here you can remember, students, this is a cell where there are batteries, small batteries combined together to give a higher amount of potential difference. That is why 2-volt batteries, there are 6 batteries combined in a serial manner, one after the other, so that the potential difference gets added up and you get the overall potential difference as 12 volts. That is how the car battery is made. Then the first one, illustrate how the 2-volt batteries are connected using the circuit symbol. This is to show that the batteries are connected in such a way that you get a 12-volt overall potential difference. Plus, minus, plus, minus, plus, minus, then you have plus, minus. You need to have 6 batteries. So here also we connect the 6 batteries. 1, 2, 3, 4, 5, 6 2-volt batteries. So overall it becomes 6 volts. Each one is 2 volt, 2 volt, 2 volt, 2 volts. So you have 6 2-volt batteries. So the overall, the potential difference will be 12 volts. You don't need to show this bracket and the 12 volts and all that. You only need to show the batteries, how they are connected using the circuit symbol. I have shown you all how the potential difference get added up. The important thing is negative terminal of the first battery is connected to the positive terminal of the second battery, and so on. You all know this because always for a current to flow, there should be a potential difference across the terminals of the batteries. And that is possible only when the batteries are connected in this manner. So all the potential differences, 2-volt batteries, 6 batteries are there, they get added up and you get a total of 12 volts. This is the diagram. This is for your understanding. I am sure you can understand that clearly. So with that, I will move on to the next part of the question. The diagram shows how the 2 headlights of the car is connected to the 12-volt battery. So here you can see this is the 12-volt battery where the 6 2-volt batteries are connected together, and that is connected to the car lights, headlights. So from the positive terminal, you can see the headlights are connected in a parallel manner. Then there is the switch. Whenever the switch is turned on, the bulb lights, headlights come on. Then you can turn it off. So that is how the circuit is connected. In what combination are the 2 headlights connected? They are connected in a parallel combination. Parallel combination. Then, draw a circuit diagram to illustrate the second method of connecting the 2 headlights. So, if you are to connect the 2 headlights in the second method, what is the second method? Series connection. How do you do that? Here you have since we only need to show the bulbs, I'm not going to draw the dry cells there. The car battery, this is 12 volt potential difference. We have the switch there. So here we will have the 2 bulbs there. So that is going to be the series combination. Draw a circuit diagram to illustrate the second method of connecting the 2 headlights, the series combination. With that, we'll move on to the next part of the question. What is the advantage of connecting the headlights in the manner shown in the diagram over the method you have illustrated in question 2, part 2? That is the previous one. So, in the diagram, if we go back and check the diagram, here you can see series combination. Now, when you close this switch, the current flows through both the bulbs, the headlights. But if, let's say, this bulb burns off, then what happens? The circuit will not be complete. So, current will not flow through either bulbs, or current will not flow through the circuit. The other headlight also will not work. And At the same time, now you have the potential difference here. When it is a series combination, the potential difference is divided among the two headlights. So accordingly, the current flow will be less. Why? When the bulb headlights are connected in a series combination, they have resistance. The resistance gets added up. Because of that, the current flow will be less. The total current flow through the circuit will be less. So the brightness of the bulb will also be less. So many reasons. One reason, when they are connected in a series combination, the resistance gets added up, therefore the current flow will be less. So you need to provide a higher potential difference for the brightness to be there, because car headlights have to be very bright. So you need to provide high current. So to do that, you need to provide a high potential difference. The other thing is, when one of the headlights gets burnt off, it's not working, then of course both the headlights will not turn on, will not light. Even if one is working, the other one is not working, then both headlights will not come on. That is another disadvantage. But if you look at the parallel combination there, now because they are parallel, the potential difference will be the same, and also you can remember, students, the resistance, equivalent resistance will decrease. So because of that, the current flow will be higher and the brightness of the headlights will be high. At the same time, even if one of the headlights don't work, current can flow through the other headlight. But as you remember, the resistance will increase. We did a calculation before. Resistance will increase, current flow will decrease, but still there will be current flowing through one of the headlights. So at least one will work. So there are so many advantages of having them in a parallel connection. We can write those down. Third one, what is the advantage of connecting the headlights in the manner shown in the diagram over the method you have illustrated in question 2, part 2. So advantages, we can say stages of parallel combination over series combination. Potential difference will be 12 volts. Equivalent resistance is less then the current flow is higher. The brightness of the bulb will be higher. That is one advantage. Then the next advantage, when one headlight does not function, the second light will function. So even if one headlight does not function, the second light will come on. So that is the advantage. Potential difference will be the same, equivalent resistance will be less, and therefore the current flow is high enough to give a high brightness compared to the series connection. And also, even if one bulb does not work, the other one will work. That is another advantage. I'm sure you all can understand that clearly, students. So with that, I will move on to the next slide. Third part of the question, the resistance of the headlights are equal to 2 ohms. Calculate the equivalent resistance of the headlights. So if one is 2 ohms, here in that circuit they were connected parallelly. What is the equation? 1 over R is equal to 1 over R1 plus 1 over R2. That is equal to 1 over 2 plus 1 over 2, 2 over 2. So if you find R, that is again going to be 2 over 2. Reciprocal is also same, 1 ohm. The equivalent resistance is going to be 1 ohm. Then the fourth part. Calculate the current flowing through one headlight when they are switched on. Through one headlight only. So through one headlight, what is the current flow? V equals IR. I is equal to V over R. What is the potential difference? The 12 volt potential difference is given to both the headlights. So 12 volts, and the resistance, one headlight is equal to 2 ohms. So 2 ohms. Then 12 divided by 2, 6 amperes of current. That is a current that is enough for the brightness of the headlight. 6 amperes current. So here we have calculated the equivalent resistance. Now this is for the circuit given to us. In that the headlights are connected parallelly. So 1 over R1 plus 1 over R2, you get the equivalent resistance as 1 ohm. And here if you calculate the current flow, you can remember, students, the potential difference across the two headlights, both the headlights are equal, and that is equals to 12 volts, and each headlight has a resistance of 2 ohms. So the current flow will be 6 amperes. Equal current flow through both the headlights, it would be equal to 6 amperes. So the total current flow through the circuit will be the sum of the two. So that will be equal to 12 amperes. You have to remember that as well. So then I'll move on to the last part of the question. Here, calculate the current flowing through one headlight if the other headlight is not working. What will be the current flow through one headlight if the other headlight is not working? It is going to be the same. Now, if we have only one headlight, then also it's going to be like that. You have the headlight here, only one headlight. And we have the 12 volt potential there. The resistance is given as 2 ohms. So if you calculate the current flow, I equals V over R, potential difference is 12 volts, resistance is 2 ohms. So the current flow is 6 amperes. So now can you all understand? Whether we have both the headlights or only one headlight, the same current, and still the light will come on. It will function. So that is the advantage of having the headlights in a parallel manner. When the headlights are connected in a parallel manner, these are the advantages. The same current flows through both the circuits because the potential difference is the same and the resistance is less. So, it is the same current. So, both the headlights will function individually and they will have the same current. So, the brightness of the headlight will also not decrease. Even if the other one is not working, still the same current will flow. So, there will be no difference in the brightness of the headlight. Is that clear to you? So, that is the advantage what we discussed before of having the headlights in a parallel manner. And with that, students, I am going to end this chapter, and in the next chapter also I will be discussing some more extra questions with you.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.